Hi everybody, welcome back. In this video we're going to cover section 1.6, the properties of exponents. So to begin, why don't we start with something something a little bit tangential to the main topic of today, but it's a nice parallel. So notice that, say I just think about something like 1 plus 1 plus 1 plus 1. Let's say we have something like this, right? So 1 plus 1 plus 1 plus 1. We know this is 4, right? And we can think about it as there being 4 ones, right? So in other words, really what we're doing is we can think about this as 4 times 1. So this all seems like kind of like common sense, but the big observation here is that that multiplication, so 1 times 4, it can always be viewed as repeated addition, 1 plus 1 plus 1 plus 1. So now we're going to segue to properties of exponents. So exponents, like let's just say 2 to the third power, exponents would be represented by repeated multiplication. So 2 to the third is 2 times 2 times 2. So you can see that multiplication is just repeated addition, and so I'll write that multiplication is just repeated addition, and exponentiation, which is just a fancy word for saying when you're looking at a number raised to some power, to some other number, is just repeated multiplication. I'm being a little bit loose with this here. It's repeated multiplication. Well, yeah, I think that's fair. It is repeated multiplication. It can be viewed that way in pretty much any case. So, yeah. So the next thing we should talk about is the first property that we're going to go over. The first property is, it's usually called the product rule. So the product rule. So now what the product rule states is this. It says that if you have some number a to the m plus n power, where m and n are just positive integers, just like 3 or something like that, then this can always be viewed as a to the m times a to the n. Alright, so I've given you the product rule, but now why don't we try to think about why this is true? So let's do like an informal explanation of why this is the case. So let's think about what a to the m plus n really means. Well, a to the m plus n, remember, exponentiation is just repeated multiplication. So just like here, in this case, we had 1, 2, 3 2's, right? So that's why we had 2 to the third. Well, with a to the m plus n, we are going to have a times a times a times dot 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 times a. And in the number of a's we have here is always the exponent. So just like up here, we had 1, 2, 3 2's, so the exponent was 3. But so here in this case, when we have a to the m plus n, what we really mean is that there are m plus n a's here. So there's m plus n of them, whatever m and n are, right? But what you can always do is you can take this you can take the m plus n a's, and you can just split them up. You can say a times dot 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 times a, and you can say here's m of them, and then times a times dot 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 times a here, and then here there's n of them. So these are really the same. So now we have to think, well, what does this expression really mean here? What is a times a m many times? Well, thinking about it in terms of this example again, we've got m a's, right? So we have a to the mth power. And here, a times a dot 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 times a, where there's n many a's, that would be a to the n. So notice we literally, it was a little bit informal, but we really just proved the product rule. We started with just the left-hand side, and using properties of using the definition of exponentiation alone, and rearranging this a little bit using some properties, the commutative property of multiplication, we note that you can split it up like this. So you end up getting a to the m times a to the n. So we actually just proved this. And in the next video, we're going to go over the quotient rule, where it'll be something of the form a to the m minus n. But yeah, we'll get to that in the next video. That's it for this video. If you have any questions, please leave them in the comments.